You're doing 3 lessons in the span of 2 days. So I'm going to give you these 2 homeworks today to be able to work on, and then just 1 more tomorrow to get done over the span of whenever. Notice, there's only 4 problems here. And there's like only 4 problems, and a couple of these are really small problems between these. So that's why I figured you can probably knock all these out today. These 2 sets, and then 3, 2, 5 we'll do tomorrow. In your table of contents for today, 3, 2, 3, I got it flipped there, and 3, 2, 4 is all about equation solving. So I think we're probably just going to still title it Solving Equations. It depends on how big you take notes. But yeah, I would just, in your TOC, put 3.2.3/4, or and 4, whatever you want to do to put those together. And it's solving equations. Except there's an I in there. And then I'm going to give you guys 5 minutes to chat about homework or get a head start or make sure your table of contents is good. I'm going to come around and check. Well, actually, I'm going to ask you guys just to come up and show me your homework because I'm going to use my laptop or my computer today. So if you can just come up and show me your math room really quickly, we'll just go straight up this row, straight up that row, straight up that row. So 5 minutes to chat with your partner, or even get started on this evening's homework. If you guys are all good with everything from last week, you can start on this evening's homework and use this 5 minutes for that. So I'm going to throw this up on the TV. So you guys can really just come on up as you see that my desk is empty, but we'll start from this side of the room and go across. Unfreeze. Unfreeze. Here's what's up. That took longer than I anticipated, but I mean, it's a new process. I'm not surprised that it's taking longer than I thought because I always have very optimistic thoughts. We may only do homework checks once a week in this class. But the problem with that is then you have to hold yourself responsible. If you have a check minus or a missing, if you want that changed, you got to come see me. Because I have planning period right after you guys leave. Those grades that I just wrote down are going in math right now. So your parents are going to see them now and ask, well, why is your homework check minus when you just had a snow day and an extra day off to get all your work done? Or missing, which is even worse. So we should all have our math journals out with a header for 323/4 solving equations. So please make sure we're on a new page, new stuff. And we look at 89. Are we done with this yet?
Yeah.
This is just like what we were doing at the beginning of the year, right? Except we might be getting a bit more complex now. A lot of us, by the way, at the end of class, if I have time, which now I think I'm going to run out of time, so I might have to wait till tomorrow, I just have to come back to you guys if we have time, so you remind me. Otherwise, you'll get that back tomorrow. You can tell me what they think this equation is. And then we got to talk about number 7 from the test. Tyler?
So here I found that every figure, it adds 6. So we thought if we multiply 6 by 50 for the 50 figures and then just add it to the total number of the first figure, we get the number.
Now when it says, I'm going to rewrite this because it breaks it up there, they say y equals 6x plus 3y. Because it was really like asking you, okay, why? Like, why do we have this and what's it going to be in figure 50? This is a lot, this is very similar to what you had in the test last week, right? The box with the extra square on top and missing square on bottom. Remember what I'm talking about? All the boxes together. Moving here?
I got thought of something. I plugged in the figure number for y and plugged in the figure number for x. And I saw.
Wait. You plugged in a 50 for here and here? That wouldn't really make sense, would it?
Yeah.
That'd be a no solution.
That's where I messed up.
So it says write this out in words, right? So who can tell me how we would say this in words? This in words. Rachel?
Like the actual equation.
Yeah, like how would we say this in words You don't have to say like y equals 6x plus 3. We mean like a verbal expression for this. What's another way you can say 7 is 5 plus 2? You can say 7 is 2 more than 5. Right? So instead of saying plus, say more than, greater than.
So 6, I mean, actually wait, so y is 6 times bigger than x,
Ooh.
and
Be careful, 6 times bigger
3
gets
x.
the, ooh, 3 more than 6 times something. Right, so we wanted a verb, and guys, this is going to be on your mastery. You might want to pay attention because we got to start to be able to speak in different ways. We can say 6x plus 3, right? We know that. But we could also say 3 more than 6.
Good morning, Caleb Smith. Please come to the office. Caleb Smith, please come to the office. Thank you.
3 more than 6 times an input, or 6 times a value, or 6 of something, because 6 means multiply. Or of means multiply, 6 means multiply. Yeah. Stop me if I say crazy things like that. 3 more than 6, whatever you want to say, times a value, 6 of a value, 6 times an input. So the reason that we do this is exactly what Tyler said. Every time we go up a figure, we are adding 6. Now this throws people up. They're like, well, you're not adding 6, you're multiplying. But we don't want to say plus 6, plus 6, plus 6, plus 6. This, part of this, means if we back down to figure 0, how many boxes would we have? 3. Which means before my pattern ever starts, quote unquote, figure 0, quote unquote, has 3. Then we add 6, right? And we get our first figure, which we only know this because we know this, right? If we don't know one direction, work the other direction. So that's why we're saying 6 times however many figures we've gone. And oh yeah, you've got that extra 3. So be careful. This is a linear function. We'll do a lot with these as we move forward. So that, if you want to jot down, is also a linear rule. So, Lou, I was trying to figure out, I think his name is just Lou. He says he has a big C made up of 45 tiles. Because he had 45 tiles to work with and he made a giant C. If the figure uses 45 tiles, what is the 45? What does that represent? Yeah?
Wait. I know the answer. I'm saying. Sorry, I just confused myself.
Okay.
Wow, I'm struggling. So, can you ask it again? The way you worded it.
If the amount of tiles needed or used is 45, is the 45 your X or your Y?
It's your Y, because 6 times 7 plus 3 equals 45.
Ah, so because the output, Y is our output here, it's the result. Our output is the number of tiles used. So on your paper, write out, and this, you should already have this somewhere, so just near that, we're going to write out 45 equals 6 times X plus 3. Well, we know that every single figure has 3 extra. Take those 3 extras away. And when we do that on both sides, yeah, our result is 42 equals 6x. Sorry, sometimes my x's connect just to not let my smartboard kind of know. It is a fish. Then we divide. Sorry, I saw your hand and my brain couldn't stop itself. And we get, Ian already told us the answer of 7. I'm going to tell you on your quiz for next week, the stuff I have planned to cover is solving inequalities, right, what we did from chapter 6 of the Math 7 stuff. Solving equations just like this. Figuring out the number of solutions involved in an equation. And then we'll see how far we get this week for what else is going to be added on. I've not made the quiz yet because we had a snow day today and stuff got moved up.
Yesterday?
Well, yeah, yesterday.
I was about to say, why are we at school?
Darn it! Why are we here? Alright. Are we pretty confident with being able to do that? You guys could solve it for 84 tiles then, I would hope.
Maybe.
Let's pick 2 of these to solve real quick. Just to practice, make sure we're good. I'm just going to give you the solutions in a moment. Pick 2 of these to solve. I'll give you like 2 or 3 minutes. For N92. N92, just pick 2 of them to solve. And then actually, so adding 2 to the top part, 2 to the middle part, 2 to the bottom part. Equation that they give us is the number of tiles so the first figure of x is uses 6. 1, 2, 3, 4, 5, 6. So these 3 were there before we then these 3 are still here. These 4 on the bottom, 4 on the top are still there. And we add we do it again here. 2 up there, 2 in there. So every time we do a step, we have to add 6. Individual steps. So how many steps on the case? Multiply that by 6. And oh yeah, we got that. Because there was 3 before we ever started. So there's like something there, and then you come up, add 6. Take another step, add 6. Another step, add 6. Answers for 92. And then I'll take questions if we have them. Answers for 92 are right here.
Wait, what? Wait, what?
I am so messed up.
Alright, give me a second. I'm going to throw those on the TV. Hold up. Hold up. Who's got questions and on what? Max? So you have half of an x on the left side, a whole x on the right side. I always try to get rid of the amount of x's closer to, well, not always, but most of the time. So I try to get rid of this half x. I'm going to subtract half x from both sides. Right? That's going to leave me negative 2 equals half of an x minus 4.
And then you take away.
Half of an x. Right? So think of an x tile. You got half of the x tile. Then, to undo subtracting 4, or you can think of get rid of negative 4. So if I write it out as get rid of negative 4, it would be this. But that's really add 4. So I do that over here, and I get that half of an x equals a positive 2. So a whole x must equal 4. Questions in B. I have issues in B that I need to look at. So by the way, what you would do formally is multiply by 2 on both sides. And that's how you get that x is 4. Ah, I meant to capture. My apologies. I'm sorry. If you need more of that, check with a partner. B, issues in B. C, issues in C being any number. Because we have the exact same thing on the left side and the right side. Once you reach the point of seeing identical expressions on left and right, any number can be your solution. What if we reach a point where we have a conflict on the left side and the right side? Like we reach 2x plus 4 equals 2x minus 2. What if we see a disagreement, an argument, Mina?
That means the problem's wrong. It's not equal to the 0 with the slash.
The empty set. So you can't, this would have been not true from the get-go. But what we're saying with the empty set is there is no value that makes this true. So saying that it's not equal then actually corrects the equation. Well, it's no longer an equation. It's like a non-equation. Issues with D, gravity. Issues with D. Yeah.
I just didn't. So I wrote it out and then I just didn't really.
My advice, subtract 2x from both
Yeah,
sides.
that's what I did.
So then you get 5x minus 1500ths equals 6/10. Add the 1500ths to both sides. Did you do that next? So you get 5x equals 0.75 after you add the 1500ths. So check your work. Because you should get to here. And then you divide by 5. And then we get x is equal to 0.15. All right. I got about 10 minutes left. We got to move on and start our next lesson. Just to get a little dabble, a little taste. So you guys have some confidence to start the homework. All right. So, redwood tree. There's a redwood forest. I've never been there. Redwood forest. Yeah. So I really, really want to go. It's like, so make your arm. How big are redwoods? Like, if you were to hug a redwood. So like, it's not like hug a red. It's like hug a redwood, right? You're like.
Even if your arms
Yeah. Right. So there's a redwood there that you can drive your car through.
Oh yeah.
They literally have a tunnel through a tree,
And the tree isn't dead.
and the tree is still alive. So. These redwood forests, right? So we can track data on trees, and there are people who do this. I sometimes wonder if I should have just gone and been a giant nerd. But if we look at this table, years after planting and height of the tree. By the way, trees only grow out of the top. So that's why if you carve something in a tree, it will always stay right there. They grow from the top. They don't grow from the ground. So, assuming the tree continues to grow, random fact for you there. Assuming the tree continues to grow at a constant rate, find a rule for the height of the tree using X and Y. So examine this with your partner. Can you determine a rule? What if we work backwards, down to 0, right? What if we anticipate forward to try to get to like 10 years? So take a couple minutes with your partner, try to figure out a rule for the height of the tree. Hold on. Talk with your partner. Red report is protected. Sky, if we look at the height here, look for a pattern. Do you see any pattern in how the height is changing? Sky. Notice I started my sentence by saying sky. Yeah, it's going up by 4. So if it does that going up, I could go backwards and do the same thing but going down. So 2 and 1. So how tall was it when they planted? All right, this is years after planting. How tall was it when planted, Oliver? So we'd minus 4 to get to 2, right? Minus 4 to get to 1, minus 4 to get to 0. We're going to take 4 away 3 times. 12, right? Because it loses 4 feet. So it'd be 13 feet 2 years after. It'd be 11 feet 1 year after.
It'd be 9 feet.
We're taking away 12, right? Not that the answer is 12. We're taking away 12. So it's 5 feet tall, right? Oh, come on. Somebody wake up.
I was saying 5 the whole time, and I was.
The 5's right. No, thank you.
So the method is multiply it by 4 and then add 5.
Okay, I was waiting for somebody to tell me this 11's totally wrong.
Yeah. I said 9.
Okay, thank you. Somebody raise your hand. You can't just shout stuff.
I said it's 9.
I'm going to start to test you guys more and more, see who's paying attention. You can't just mindlessly be writing things down here. You also can't just be waiting for somebody to give you answers. More and more, as we get into second semester, you got to be thinking. Okay, don't rely on me up here. So, drop 4 every time. So, who was just trying to give me the equation? Sorry. So, you said multiply by 4. So, if I say the height of the tree is 4 times t, but what else is there? Add 5, because it was 5 feet at its planting date. So this is our equation. The height is 4 times t plus 5, where t is time in years. Don't use y, because y is a variable that we use. Use t for time. Don't use y for time. Because every year it's growing by 4. That is our rate of change.
Oh, okay.
Right? So that's like our unit rate.
The tree's going pretty tall.
It's irregular. Right?
It's going pretty fast.
So, after 6 years, how tall is it? 29, somebody said. After 7 years?
34.
33. Be careful because we're adding 4 every year. This 5 is what it started at. Now, this gets annoying to do this every single year. This is why we use the equation. Stop adding 4. Stop with the addition, right? That's triangle. Use your equation, plug in how many years. So, T's time, how many years, right? Time.
Oh, yeah.
10 times 4
Oh, 45.
plus 5. The height is 45 feet after 10 years. 20 times 4 plus 5. Could we solve after 100 years?
Yeah. That'd be 400.
And we don't need to add 5, add 5, or add 4, add 4, add 4, add 4. No, that, you would like go crazy. Use the equation to solve for your unknown.
How old do you guys live?
I mean, hundreds of years. They live to be really old trees.
So they get like insane tall.
That's why red before is so impressive.
So they don't stop them.
So this, Bilal asked a good question. This is assuming the tree continues to grow at the same rate. Right? It's growing continuously. Eventually, we probably assume the tree would slow down. And then, going deeper than we really need to go, is that's up there. So we're going to start to graph other situations. And actually, there is a question, question 97. Please do question 97. It asks you to make a graph. You're going to need some graph paper. And I'm aware of that, so when I go to check your homework, if you don't have a graph for 97, it's going to be obvious. But imagine, give me a minute, you can start to pack up if you want, but please do so quietly. Imagine that we're graphing the height of the tree compared to time, and we're steady, 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 and then we start to slow down. This is going to make a situation that we often call exponentials, and we'll get there to dealing with those. You also have graph situations called parabolic, where things, if I throw a ball, give me your eyes for a second. If I throw a ball or anything, think about height compared to time, right? So imagine this, height compared to time, right? It goes up, it goes down. It's easier to see if I go up and I go down, and I don't catch it. But it didn't hit my coffee, so that's okay. When I model things that deal with gravity, like my coffee cup last week, that's why it's broken, it goes up and then it goes down. And there's a peak point where it stops going up or down. It just sits still and then it comes back down. That's called parabolic, or a parabola. So, there's a lot of types of graphing. 97 is a weird question. Please graph it. Please solve it. Remember, squaring a negative is positive. Have a good day. See you guys. Yeah, you can. Use graph paper is easier. I'm trying to make your life easier. Tomorrow. We're checking homework and everything today. I kind of guessed it. It's ready. If people are dying to get their papers back to me, they Yo. Not sure.